Hey everyone, welcome to the Mid-Unit 7 review. Here, this is just over sections 8.1 and 8.2. So I'm going to go ahead and I'm going to just focus on the odds, and you can complete the evens on your own. So looking at these tables to start, we just need to determine if it's direct, inverse, or neither. So with that, you have to calculate your constant of variation. So if it is direct, I'll write it up here. If it's direct, then you'll just have a equal to y over x. And if it's inverse, you'll have a equal to, you multiply them together, x times y or y times x, it doesn't really matter. So I'll say a equals xy. Okay, so I'm just going to test those two things, and if it's not the same number over and over again, then we'll say it's neither. So let's see if it's direct. We're going to do 38 over 2, and that's going to give us 19, and then I'm going to do 19 over 4, and that is just going to spit out 19 over 4, so it is not 19. It needs to be 19 every single time. So it's not direct. So let's move on to inverse. So if it's inverse, we can multiply them together. So I'll do 2 times 38. That's going to get you a value of 76. So I'll move on and I'll do 19 or 4 times 19, and that's going to get me 76. And so I'm going to do 9.5 times 8, or 8 times 9.5. The order doesn't matter. Sometimes I say it backwards. That's still going to be 76. And then 10 times 7.6, you can imagine that that is going to be equal to 76. So it looks like this one is going to be an inverse equation. And remember, inverse is a division equation, and direct is a multiplication equation. So to write your equation, you just take that a value, we got 76, and we just say 76 divided by x. So that is all I'm looking for on this type of problem right here. So let's move on and do number 3. So number 3, we have 1.5 and 9. So I like to start testing direct first. And so if it's direct, here I'll write D-I-R. If it's direct, we'll divide them. 9.5, or 9 divided by 1.5 equals, and that's going to get you 6. 24 divided by 4 gives us 6. 39 over 6.5, that gives you 6. And then 60 over 10, 60 over 10 gives you 6. So that means it's got to be direct. And so we just say y equals, and then that a value we just figured out was 6, so y equals 6x. And that is going to be the answer to number 3. Okay, so if you're doing the evens and direct and inverse don't give you the same number, then just say neither. And you don't even have to try and make an equation with that. You just say neither and move on. So in exercises 5 through 7, the variables x and y vary inversely. Use the given values to write an equation relating x to y, then find y when x equals 3. Okay, so varies inversely. So that's the key word here. That means we have to do a equals x times y, and then we have to convert that and say y equals a over x for our little equation. So I have x and y here given to me, so I'm going to say a equals x times y, 6 times negative 5. That's just going to be negative 30. So y equals negative 30 over x. And then it told me x is 3, so y equals negative 30 over 3, which is negative 10. So there we go. There's every answer to this question right there. So number 6 should go something like that. And so 7, 8, 9, 10, we're going to be filling out this table. You're identifying the vertical asymptote, horizontal asymptote, domain, and range. So remember, if there's only an x on bottom and not an x on top, for your vertical asymptote, no matter what the style is, the vertical asymptote is set the denominator or the bottom of the fraction equal to 0. So x minus 1 equals 0. That's going to be positive 1. So x equals 1. I'll jump down to number 9. 3x minus 1, set that equal to 0. So in this little space, I'll try and write real small. And I get 3x equals 1, divide by 3, and x equals 1/3. That's my vertical asymptote there. All right. So my horizontal asymptote, if there is not an x on top, you just look at the number on the side. Hey, it's missing a number on the side. So we just say y equals 0. Remember, there's always going to be a vertical asymptote and a horizontal asymptote. Don't say that there's none. And so like on this one, if the number -5 is on the side, that's your horizontal asymptote. This one, you have no number on the side, but you have an x on top and on bottom, so you divide those. So I'm going to say y equals 6/3. But we know what 6/3 is. That's 2. So I'm just simply going to say y equals 2. Okay? So now I've identified my asymptotes. Let's just identify our domain and range. Your domain will be your domain and range will be all real numbers, except your domain can't equal whatever is in your asymptote, and your range can equal whatever is your horizontal asymptote. So we're going to write our domain like this. We're going to say x. We're going to put this kind of bracket, x, the such that line. And you say x equals 1 for the asymptote, so we're going to say x is in all real numbers such that x can equal 1. Then we're going to go back and we're going to look at our horizontal asymptote. We have y equals 0, so we're going to say y is in all real numbers such that y can equal 0. Okay, so make sure you are writing your answer exactly like this, and that doesn't look very neat. Make sure you're writing your answer just like this. Don't just write what it can equal. You have to put the y and the such that line. That tells you it's all real numbers, this little statement right here. And then this is the condition. The condition is you just can't equal 0. That's it. So here we have 1/3 and 2. So x is in all real numbers such that x cannot equal 1/3. And then we'll say y is in all real numbers such that y cannot equal a positive 2. And so that's all I'm looking for on the domain and range there. So now we're on to the back, I guess. And so in exercises 11 through 13, describe the transformations for each equation. So your transformations, you'll notice that there's only an x on the bottom, not on the top. So it makes it pretty easy, or easier, I should say. Remember, your inside is on the bottom of the fraction, so +1 makes it go left 1. And, you know, I tell kids, if you get confused with this stuff, think about it. Your asymptote, your vertical asymptote, is at x equals -1. So a -1 makes it go left 1, doesn't it? So hopefully that makes sense. Your horizontal asymptote is at y equals 3, because that's just on the outside. So that means that's going to tell me that my transformation is up 3, since it was y equals 3. So these are really the two answers that I'm looking for, the left one and the up 3. I just thought I'd expand on that by pointing out your asymptotes, that's all. So let's move on to number 13. So here we have x plus 4. So that means your vertical asymptote, set that equal to 0, you get x equals -4, which means it went left 4 units. Okay, and then this -2, that tells me my horizontal asymptote is at y equals -2, which means that went down 2. All right, so I'm just looking at these for the official part of the answer, but I do think it's important to know where your vertical and horizontal asymptotes are and how they affect your transformations. The only thing I left out was this negative. Anytime you see a negative on the outside, what does that mean? That means it's an x-axis reflection. Negatives on the inside are y-axis reflections, and so that would mean there'd have to be a negative on the bottom of the fraction. So that would be kind of weird looking. So yeah, just count on it basically being an x-axis reflection, I would expect. But yeah, so let me just spell out reflection. Okay, there we go. And so that's everything on number 13. We're not even paying attention to the 3 on top or the 2. We're just identifying the left and the up. So now let's move on to number 15. Here you're given a graph. So you're going to graph the function and label the vertical and horizontal asymptotes. So what is our vertical asymptote at? Set that denominator equal to 0. So that would make it at -6. And then your horizontal asymptote is that number on the outside, so y equals -3. So what you're going to do is you're going to go over to x equals -6, and you're going to draw like a dashed line. It could be a solid line if you want, but I don't know. I prefer dashed lines for asymptotes. And then we're going to go to -3 on the y, and I'll draw another dashed line. I don't think there's a rule that says you have to do a dashed line or a solid line, so I just choose to do a dashed line. And so now we need to graph this. So I'm going to type this in. I'm going to type that in, and I'm going to press Control-T and the graph. And then I'll get a few points that I can safely graph, meaning where I can plot them on the corners. I want to avoid like the decimal values, you know. So looking at my table, I see there's a -7, -10. So I'm gonna go 7 left and then 10 down, and so that'll be right here. And then I see a -5, +4. So I'll go -5. +4, put a dot right there. What other ones are kind of easy to graph? I think if it's at 6.5, it's kind of easy to get. So I see a -8, -6.5. So that'll be about right here. What's at -9? -5.3. All right, so I guess I'm kind of going against what I'm saying. So -5.3, that would be, I guess, about right there. The key is our graph is going to be going like this, because -10 is at -4.75, which is about right there, yeah. So we have that. Doesn't look that good, but it counts. And then I'm going to go back to this one up here, and I had -5, 4. I had -4, 0.5, so -4, 0.5 would be about right there. 3 is at -3, -6.7, so -3, -6.7, so that's below, about right there. And then -2, -1.5, or 2.5, -2, -1.25, so that, I guess that's about right there. And -1, -1.6, so that'll be about right there. I have 1, -2, so that one's nice. The 0 is at -1.83, so if you notice, it's kind of just curving like that. And I'll graph like 2 more. So we have +2, -2.125, and then +3 is at -2.2, and then +4 is -2.3. So as you can tell, it's basically just, it's approaching that asymptote. So it's just going to kind of skirt along that asymptote like that. So that's what I want you to do for your graph, is to actually graph it on the graphing calculator and then press Control-T, please, and then please plot me some real points. Don't just, this is what I don't want to see. I don't want to see just kind of a lazy graph like that, okay? No teacher is going to count that right. What we want to see is we want to see the asymptotes graphed, okay? So the two lines, one vertical, one's horizontal, and then I want you to go Control T and plot as many points as you can to draw a decent enough looking graph, okay? So that's the last one on the review. Thank you for watching. Like, comment, and subscribe if you want. I don't know. Goodbye.